name's John, and I just graduated from the University of DC this past spring, where I got my bachelor's degree in mechanical engineering and a focus in advanced manufacturing. Since graduating, I've been working at NASA Johnson Space Center as an intern working remotely on thermal engineering. Prior to beginning this internship, I was working at the CAMSTAR program at UDC, where I was trained in how to use the school's Direct Metal Laser Sinterer, which is a metal 3D printer, one of a few of its kind in the DC metro area. And the printer has tremendous applications for things like aerospace, where you can build and design and then print objects which are not capable of being manufactured through traditional means. This means you can create things like rocket nozzles or support structures, which are incredibly complex geometrically, but you can then build and test very rapidly through this printer. The CAMSTAR program has been able to support my training on this unique piece of equipment. Has also given me a huge leg up on things such as graduate programs. I'll be starting my PhD at Cornell University this fall. And one of the areas that really helped was having actual hands-on experience using this equipment, which is not particularly common for undergraduate students. This has also helped kind of prepare me for this summer at NASA Johnson Space Center. So as I mentioned, I'll be doing thermal engineering, which is not directly related to advanced manufacturing, but does have a number of links. For instance, the metal 3D printer has a very complex relationship with the metal that you're printing. You get very rapid heating and cooling of areas, which changes the crystallographic structure. And this all can be modeled or simulated numerically. Similar to what I'd be working on over the summer. Now, I am doing something that's a little bit different, and that is doing assessment of variable emissivity radiators for NASA. These have applications on lunar rovers and landers. And one of the things that makes them interesting is they can change how much heat that they emit based on what temperature they are. This can either be controlled by a processor or purely by the temperature gradient. So these have actual potential applications in future missions. So what I've been doing is modeling and simulating various designs, doing design studies, and then analyzing the cost-benefit ratio for all of these different designs. And this gives engineers at NASA a great way to kind of evaluate very quickly what potential areas they might want to look into in future missions. As you may be aware, NASA is very invested in sending people back to the moon, and we have a number of landers and other missions slated to begin in the next 2 years. So that includes landers and rovers and that sort of thing. One of the things that CAMSTAR has helped provide experience with is modeling and simulation software before starting at NASA Johnson Space Center. Experience with programs like COMSOL and ANSYS Workbench are somewhat similar to the programs that I've been using, predominantly Thermal Desktop, which is a thermal engineering analysis tool, as you might guess. So getting that hands-on experience earlier really makes the learning curve a lot easier as far as learning a new piece of modeling software, as complex as it might seem from the onset. Ultimately, this is providing incredibly valuable experience for me before I start up my PhD program. Some of these software tools will actually be pretty useful for my research once I start getting into it, whenever we're allowed back on campus, that is. And it gives me kind of a leg up as far as potentially working at NASA in future, which is one of my goals, hence why I'm going through a PhD program, so I can continue doing research and do that at one of the world's premier research institutes. For those of you interested in a career in engineering, I would really suggest that you look into joining the CAMSTAR program at UDC and trying to get great internships like the ones they provide at NASA. These are great both for a resume if you're looking to get a job straight out of school, or they're incredibly valuable if you're looking to get into a graduate program, as graduate programs for engineering by and large are very competitive. And having something on your resume that shows that you actually need to do real engineering, you've learned how to do modeling, simulation, you learn how to get hands-on in a lab, are probably some of the most valuable things you can put on your resume outside of your GPA and that sort of thing. So um, definitely take a look at the program, and yeah, I would encourage you to get hands on as soon as you can.